Okay, so everyone should be looking at this worksheet right now. Okay, what you're going to start with, I'm going to give you only like 10 minutes to do this part in your groups, okay? And you're all doing this individually. I want you to fill out this chart. What the chart is asking you to decide is, are the shapes in like the sets, are they the same shape? Are they the same size? Use your patty paper to help you make your decisions, okay? So I'm going to give you guys like 10 minutes to just fill out the top of this chart here, converse with each other. Once I feel like everyone's done, we're going to get together and talk about it.
Doesn't that make the same the shape? You can go in No, my dad.
I can't spoil it. But yeah, keep that in your head when we talk about it, okay? Nope, don't do the back yet.
So it was so easy yesterday. The 555 like the 100. Yeah, he was better than that. Yeah, I know.
If it's just the questions from the gym, I think that's
not.
maybe like a little bit of
What is the purpose of taking apples?
How we coming out there?
Oh. What Lucas, what's the purpose of gloves? To get your hands dirty.
protective.
Well, I thought you would keep protective gloves.
Yeah. No.
Rubber gloves are just not gloves.
Something I still have been told.
I had a cold out there. Bro, I
One day.
my mom.
I did 3 points better than him on the next test. He sucks.
Bro, Lucas.
I got like 64 points in science. I didn't worry out by nothing.
All right, it's looking like most of you are done. So let's talk about this front side here together. Okay, so starting up here with these, I don't know, they kind of look like lightning bolts to me. What did you guys say? Are they the same or not?
No.
Well, I got a yes and I got a no up here. You guys say no back there? Why? I've traced it. What'd you guys try to do to get it to look the same? Rotate it? Okay, so I'm going to do that up here. I'm trying to rotate. Is that matching?
No.
No. If I try to like line up the bottoms, they don't really match. This one also seems like it's a little bit bigger. Do you guys agree with that? What if did anyone try to like reflect it and see if it would work that way? Does it work to reflect it? No. Okay, so I don't think these ones are the same. So I'm going to go ahead and say no over here. No, and I'm just going to say they don't match. What about the second one?
Yeah.
Yeah? What'd you guys do to get them to look the same?
Flip them.
A reflection?
Or, yeah.
So I'm going to flip my patty paper upside down. And then if I put it over, does that line up pretty perfectly there?
Yeah.
Yeah. So I'm going to go ahead and say yes for number 2. And I'm going to say used a reflection. Okay. What about the third one? Logan?
Because since there is 2 triangles there, you could rotate them or reflect them to make them line up.
Okay. So I traced the first set of triangles. If I were to take these and move them over here, are they the exact same? Would you say they're the same size?
Yes.
I mean, when I slid this over, does this second shape, if I put it on top, does it get any bigger or smaller than like the ends of those triangles there? No, so I think they're probably the same size. Are they made up of the same shape though? Yeah, like these triangles are just put in a different order. Like if I take this over here, this top triangle would match with maybe the bottom one, and the bottom triangle would match with the top one. Okay, or I mean, if I flipped it around, I think it's still going to do the same thing because it's the same 2 triangles being used. So this one's a little bit deceiving because they appear different in just how they put the shapes together, but they are still the same shape. I'm just going to write up here that my triangles match. And I'm just going to write down here, they're just rearranged. They just move the triangles around a little bit so they're positioned a little bit differently. All right, how about this last one? Are these the same? Shh. No, why not?
Different sizes.
Different sizes? Like if I take this over here, I can already tell that the one I traced is a lot smaller than the other one. I'm trying to move this around to see if I can get them to line up. It doesn't really seem to want to do it. Like they're just different enough, not by much, but just a little bit here that I can't even really get this to line up because I'm trying to even just get some of these points to go in. It's not working. Even if I try to do a reflection here, I mean, that's close, but it's still like down here in this area, it looks a little weird. And so I don't think these ones are the same at all. And like I said, they are even slightly different sized. So I'm going to say no for this one. And again, I'm just going to say they don't match. Okay. Part B is saying, what does it mean for 2 figures to be the same size and the same shape? What did you say, Keegan?
Congruent.
What does congruent mean? Means equal? We talked about congruent at the way beginning of the school year when we were doing that unit with constructions. And we talked about like a lot of vocab. We went over the difference between things being congruent and things being like equal to each other. But we said congruent was when they're the same shape, same size. So congruent means they have to be identical. Remember we had that symbol for congruent that had that equal sign with that little squiggly line on top of it? So up above, the only time we were able to say yes is when the shape that we were using between the two things was the exact same. The last couple of days, you guys have been working with performing reflections, rotations, and translations, right? All those shapes that you guys did that with were congruent. You haven't had any situation that you ran into yet in this unit where something was being dilated or stretched. All the triangles stayed the same or all the rectangles stayed the same, okay? So tomorrow we're going to talk a lot more about like the details behind congruent and like what does that mean when you're given two congruent shapes? What can you do with them? But what I want you guys to do right now with me is turn your page over and look at the back side. What do you think is safe to assume about all these triangles?
They're congruent.
They're probably all congruent. They're all the same shape, same size, okay? Now down below, what it's asking us to do is for each pair of triangles, list the rigid transformations. What are your rigid transformations again?
Isometric.
The isometric ones. What were the three that we've been working with this chapter?
Translation, rotation, reflection.
Translation, reflection, rotation. Okay? So those three things, which ones could be used to show that the triangles are congruent to each other? Make sure we're using proper notation when describing our transformations. We are going to do some of these together. Okay? Whatever we don't get done in class today is your homework. So the more we get done together, the less you guys have to do on your own. Okay? First period, they had to do like 4 on their own by the time we got done. So, but they're also extremely quiet. So if you guys are more willing to talk to me and tell me what you're thinking, we might be able to get it done. Okay? What I'm going to have us do down here is they're looking at two triangles that they want us to get together. Now, we're going to kind of think about those composition of functions that we did yesterday, where we're combining. Maybe we do a reflection first and then we do a rotation, or maybe we do a rotation and then we do a translation in order to get these triangles to match up. So some of you might be able to see this done one way and someone else might think, well, I would have done it this way. Okay? There's more than one answer that you can write for a lot of these problems. The other thing I just want to point out on your picture up here is they are putting other points, like Q is right here where those 4 triangles mesh. P is right here. You can use any line that you want to reflect, and you can use any point that you see on this graph to do a rotation. So you don't just have to do the origin, but I know sometimes we're comfortable with that. But just know P and Q can also be used. Okay, so let's just start with number 1. We're trying to go from triangle 3 to triangle 10. I would still encourage you to use your patty paper because that you can trace the triangle and then actually manipulate your patty paper to figure out what's going to work. So I'm going to come up here and I'm going to trace triangle number 3. Okay, and I want to get triangle number 3 to go to triangle number 10. Any ideas? Anyone have a thought? How can I get this triangle 3 to go to this triangle 10? So that's using a reflection. What do you want to flip it over? The y-axis? Okay, so let's write that down here. How would I write that notation-wise? What do we use for reflection? Lowercase r. And then you said the y-axis. So I'm going to write y-axis here. And I'm doing this to triangle number 3 at the moment. Okay, so now I'm going to do this up here. So I've got this traced. And I'm just going to draw a little bit of that y-axis so I know where to line up my paper. I'm going to flip my paper over for my reflection. I've got my y-axis lined up. I'm right next to triangle 10. So if I do my y-axis, which is fine, I'm going to have to do a second transformation now to get it to go over a little bit. What should we do to get it to push over? Translate it how much? -3. I'm going to check that. I'm right here. So I'm going to count 1, 2, 3. That would get those like bottom corners to match. And if I do the tops, 1, 2, 3. So he's right. How do we write that though? Down here. Capital T. What's that called? Vector. And what numbers do we put?
-3, 0.
-3, 0. Good. Before we move on from this one, can anyone think of a way that you could have done that in one movement? Could we have reflected over a different line and gotten it to line up exactly? You don't think? Greer?
Okay, reflect over x equals -1.5.
-1.
4.5.
1, 2, 3, 4.5 would be here.
Yeah, -1.
-1. So I'm going to just kind of draw a little dash there. If I were to reflect over this line, guys, so I'm going to take my paper, I'm going to flip it, I'm going to put that back on -1.
-1.
I think it should be -2. -2. But if I did it over -2, they would have lined up in one movement instead of having to do two. But it's okay that we did two. But this would be one of those things of you might see the one movement and you may want to do that so you don't have to write out all this extra stuff. But you could also still do what we did. Reflect over maybe what you're comfortable with and then do something else. Okay, let's do number 2 now. What triangles are we working with for number 2?
1 and 12.
1 and 12. All right, so triangle 1, you can either use like the same triangle that you traced earlier because you should just be able to kind of turn your paper and get it to line up. Or you can retrace the triangle, doesn't really matter. Okay, I'm on 1, I want to get to 12. What do you guys want to do? What do you want to do, Logan? What did you say? Rotate around the origin? Okay, so here's my origin. I've already got triangle 1 traced. 90 degrees, so I turn my pad paper which direction? Counterclockwise. 90 degrees, he said. So it'll be right there. So I'm going to write that down. What do I use for rotation? Capital R. What do we use for the center? Origin. So O, and we did 90 degrees. Okay, so right now I'm sitting like on top of 13. I got to get to 12 though. Reflect on the x-axis. So little r, x-axis. And again, we're doing that all to triangle 1 to get it. Because then if I fold that over right there on that line, it should line up on 12. Good. What about number 3? We're trying to go from triangle 10 to triangle 6. Here's 10. And if you're not quite sure maybe how to start, how would you get the triangles to be faced in the same direction? Maybe that's where you would want to begin. So I'm here right now. Keegan, what do you want to do?
Could you reflect over the origin?
Usually we reflect over a line, not a point, like the origin.
Like 0 then?
What do you mean when you say 0?
Like y equals 0, just like straight up and down.
So that if it would be y equals 0, that would be the x-axis.
For the y-axis then?
So you want me to reflect it this way? Do you want me to reflect over the y? Or do you want me to reflect over the x?
X.
X? That way it'll get to be the same direction as 6. They're facing the same way now. But yeah, if I do a reflection over the x-axis, so I'm going to write that down here, little r, x-axis, triangle number 10. Now it's right here. How do I get it over here to 6? Translation. We got to just figure out how much. So right now I'm here. How many is it? 15. Is that what you said? Yeah, I agree. 15. How do we write that down here?
Or T, vector.
Good. Again, there's lots of ways that you could do that. If you wanted to do a different reflection, like you could have reflected it over something else instead of doing it over the x-axis. You could have chosen a different point, or you could have tried to do a rotation. But yeah, most of these should be able to be done in like 2 movements. Some might require more, some might require less. It just kind of depends on how you can see it going. You want to keep going, guys, together?
Yeah.
Okay, next one. Number 4 wants us to go triangle 11 to triangle 7. All right, triangle 11. I want to get to 7 over here. What do you guys want to do first? Rotate it around. So this point Q? Okay, so let's rotate it around Q. How many degrees do you want me to go? 90?
Negative 90, sorry.
Negative 90. So like that? Okay, so I'm going to write that down here. We did capital R. We did it around Q. We did negative 90. We're doing that to triangle number 11. So let me do that again. So I'm at 11, negative 90. It's sitting right on top of 10 right now. I need to get it over to 7. What should we do to get it over to 7? What do you want to reflect it over?
The y-axis.
Okay. So I'm just going to draw a little line here through my y-axis. And I'm going to do my reflection. So I'm going to flip my pad paper over. I'm going to line up that mark I had. So it's over here. We're getting closer to 7, but we're not quite there. What do we need to do to finish this off? Translation. We got to slide it over. How many points?
4.
I think 6. If I'm counting like point to point. 1, 2, 3, 4, 5, 6. 6 to the right. Okay, so down here, we've got our rotation written down. We've got our reflection written down. Now let's finish off with our translation. And how do I write my vector?
Uppercase T, vector, 6 up.
Good. Okay, do you guys want to keep going or do you want to work on the rest by yourself? Okay, we can keep going. Triangle 4 to triangle 13 is what number 5 says. What do you guys want to do? Rotate it? Let's see, I want to get this. What do you want to rotate around? The origin? How many degrees? Okay, so I've got my pencil on the origin. We're going to go 90 degrees. So we'd be about there. We all good with where that's at right now? Okay, so let's write that down. So we did a rotation, so capital R, around the origin of 90 degrees. We did that to triangle 4. We need to get to 13. I'm up here right now. I'm like right above it. You're close, Parker. I agree we're going to do a reflection over this line, like right here. Like this line that's in between. So 3 on the what axis? So y. So it'd be y equals 3. So down here we're going to write little r and then y equals 3. Again, we're still just doing that triangle 4. That triangle that I'm writing in the parentheses is just the triangle that we're moving. Okay, just like you would have triangle ABC or something else, but they're just all numbered, so that's why I'm using that notation. Okay, number 6, triangle 5 to triangle 6. They're really close to each other. What do you guys want to do? What are you saying back there? Rotate around P negative 90? Okay, so capital R. We used P this time. Negative 90 degrees to that triangle 5. Okay, this is where it's at in my picture right now. What do we want to do now? Keegan? We want to reflect it. I agree. We got to figure out what we're reflecting over. Greer, what do you think? Okay, let me think where that 2, 3, 4, 5, 6, 7, 8 right here.
Oh, wait, no, sorry, 7.5.
7.5. Yeah, I think if we want to do a reflection here, that's going to get it exactly on. We're going to have to be in between 7 and 8, which would be 7.5. Because if I flip that over and I line that back up, it's matching. But again, it's right in between square 7 and square 8. And it's okay to do that. That's just being resourceful. So we're going to write little r. And it went through the x-axis because it's a line that goes up and down. And we said it was at 7.5. Again, that's not the only way you could have done that. Some of you might have done a reflection maybe over just a whole number, and then you'd have to do a translation just to kind of shift it so it matches slightly. All right, we've got 4 left. We still doing okay? Okay. 6 to 8. What do you think? 10.5? Let's see where that's at. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you want to reflect over this line right here. Because it's just halfway in between. So that would get us to just do one movement and it should just flop over and look the same. How do we write that down here? Good. That was one movement. Thank you. All right. Triangle 9 to triangle 11. Macy. Around. Okay. So be right there. Okay, so I'm going to write that down. Number 8, I'm writing capital R around the origin, 90 degrees. And I'm doing that to triangle 9. So now it's sitting right on top of 12. I want to get it to 11 though. So what do we need to do here? Reflect it over what? X equals negative 6? Because that'd be this line right here. And if you just count 1, 2, 3, 4, 5, 6. There's that notation for number 8. All right, we're almost done. 8 to 10. What do you want to do, Logan?
I'd love to do, I started with rotating the 180 around the origin.
Okay, 180. Whoa. So right there?
Yeah.
Okay, so down here for number 9, I'm writing capital R. O for the origin, 180 degrees this time. Triangle number 8. I wanted to get to 10. I'm right here. I'm right here. I want to get it to here.
Translation.
Translation of
7.
1, 2, 3, 4. I think 6.
She's going to see it from here.
It's hard. 1, 2, 3, 4, 5, 6 is what I'm getting. I think 6. So I'm going to write. How do we write that down here?
6 comma 0 on the vector.
Good. All right, last one, guys. We all good now?
Yeah.
Okay, last one. 2 to 4. What do you guys want to do? You want to flip it on the x-axis?
Yeah, because then you can translate it.
Okay, so R, little r, x-axis, triangle 2. All right, so if I do that, I'm right here. And I want to get up to 4. So just think about this corner right here. I need to get this corner up to here. So what directions do I need to go?
Right.
Right?
3.
1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, so we said right 3, up 6. How do you guys write that down here in a vector?
T vector 3 comma 6 vector.
There you go.
You always turn this in.
Yes, I would like you to turn it in. Everyone should be able to turn it in.
Yeah, you do.
Okay, I did 10 a little differently. So I rotated around right there.
Yep.
Would that still be y equals 4.5, or what would that be? Because it's y and x I'm rotating around, technically.
Let me check it here. Let me